kids, here's what we're going to do. Here's a video. If you watched the first video and the Pearson video, here are some problems to help you practice your skills to see if you're doing everything okay. Why don't you take out a piece of paper, open your book, and take a look at these problems. Here's our first problem, number 12. See if you can solve this problem. Pause the video and see if you can solve it. All right, here we go. Again, we're comparing rates, and so what we want to do is read the problem, make sure we understand it first. On some days, the temperature changes quickly, okay? On Monday, now this is important, on Monday the temperature changed 30 degrees Fahrenheit in 6 hours. On Saturday, the temperature changed 44 degrees Fahrenheit in 10 hours. And the question they ask, on which day did the temperature change at a quicker rate? Well, in this case, the answer, if you did the work, you found out that it was Monday. And here's how you would solve it, okay? One of the things that you want to remember is you want to set up your initial rates first. So on Monday, we had initial rate of 30 to 6, okay? So we had temperature to hours, okay? 30 to 6. On Saturday, your initial rate, again, was temperature per hour, okay? Temperature increase per hour. And then what you want to do is you want to find your unit rates. So in this case, you're going to divide by 6 to get 1 hour. Okay, 1 hour. You're going to divide by 6. And then 30 divided by 6 is 5. So in this case, what you have is you have an increase. The temperature will go up 5 degrees for every hour. That happens on Monday. On Saturday, you're going to divide by 10 to get a unit rate of 1 hour. And you can see that if you divide 44 by 10, you get a temperature increase of 4 4/10 per hour. And so in this case, you can see that 5 degrees is greater than 4 4/10. So that's how they came up with the answer for Monday. Let's take a look at another problem. See if you can solve problem number 14. All right, hopefully you paused the video and restarted it to see the answer. The school district requires a 15-to-1 ratio of students to adults on a field trip. About how many adults will be needed for a field trip with 72 students? Well, the easiest way to solve this problem is to simply find out how many adults you're going to need. How many sets of 15 are in 72? Well, in this case, you would divide 72 by 15, and you get 4 8/10. Now, of course, you could create a ratio in order to solve this problem, but the important thing here is to remember that you can't have 8/10 of an adult. So you're going to have to round that up to 5 adults, okay? You're going to have to round it up to 5 adults, all right? So, next, let's take another look at another problem. See if you can solve number 16. Pause the video. All right, here's a classic example of a good problem. Julia is shopping for a new car and cannot decide between two of them, a red car and a black car. The red car can travel 360 miles on 20 gallons of gas. The black car can travel 336 miles on 21 gallons of gas. Based on gas mileage per gallon, which car should Julia buy? So again, what we want to do is find miles per gallon to answer this problem. And so the first thing we want to do is set up our initial ratios. The red car at 360 to 20 gallons, and the black car at 336 to 21 gallons. And then what we do is we divide to find a single unit of gasoline. So we will divide by 20 to get 1 gallon of gas. Divide 360 by 20 and get 18. So the red car is going to go 18 miles to the gallon. So it is a ratio of 18 miles per gallon. That's its miles per gallon. Okay? And then if we want to find the black car's unit rate, we would divide both terms by 21. That would give us 1 gallon, and it would give us 16 miles to the gallon. So in this case, you can see where the black car, okay, its gas mileage is 16 to 1. So this car right there is going to give you the better gas mileage per gallon. All right, let's try one more. See if you can solve problem 18. Pause the video. All right, here we go. Darius can run 25 meters in 4 seconds. Patrick can run 50 meters in 10 seconds. Which boy runs at a faster rate? Well, in this case, first we want to take a look at Darius and his rate. He runs 25 meters in 4 seconds. So this is meters, and this is seconds. And again, you are comparing distance to time. And if we want to get a unit rate, we're going to divide by 4. Divide both by 4, and you get a unit rate of 6 25/100 to 1. Okay? And then if we want to look at Patrick's, Patrick has a 50 to 10 rate. If we divide both terms by 10, we will get a unit of 1, and another term we will get 5. So in this case, it would be 50 meters for every, or I'm sorry, 5 meters for every 1 second. This would be 6 25/100 of a meter for every 1 second. And so you can see in this case, okay, that Darius is running faster. And the reason he is running faster is because he is going a farther distance in the same amount of time. Okay? All right, hopefully that is, those example problems helped you understand a little bit better. If you have more questions, you can certainly see your teacher or see your parents for some help.